Hello everyone, welcome to question number 3 of advanced trigonometric series. Now today's question is, show that by eliminating x and y from the three equation, that is the first equation is sine of x plus sine of y is equal to a. Let's say this is our first equation. Second equation is cos of x plus cos of y is equal to b. That is our second equation. And our third equation is tan of x plus tan of y is equal to c. Now by eliminating, we have to show the moment you eliminate x and y from the equation which is left in a, b and c, which will be this one, we have to prove. So let's start with the third equation, that is tan of x plus tan of y is equal to c. Now here I'm going to expand tan of x in the terms of sine and cos. So I'm going to write this as sine of x divided by cos of x plus sine of y divided by cos of y here is equal to c. Now let's take LCM. So you'll get sine x cos y plus sine y cos x. I think that is the expansion of sine of x plus y whole divided by, I think you'll get here cos of x and multiplied by cos of y is equal to c. In general, I remember this result, tan of x plus tan of y is equal to tan sine of x plus y upon cos x cos y. You can remember this as a direct result, or you can take LCM and calculate this. Now here I'm going to multiply and divide by 2. The purpose I'll tell you later on. So this will be 2 sine of x plus y is equal to c, whole thing divided by here is divided by cos of, I can write this as x plus y plus cos of x minus y, because the moment you open this cos x cos y plus minus sin x sin y, and this will be cos x cos y plus sin x sin y. So sin x sin y will cancel out, you'll left with 2 cos of x and cos of y. Now let's call this equation as fourth equation. Now I'll tell you the objective y I multiplied 2 here, this 2 y I multiplied here. The moment I multiply, I got cos of x plus y and cos of x minus y. And here we in numerator we have sine of x plus y. So from first, second and third equation, if I'm able to generate sine of x plus y, cos of x plus y and cos of x minus y, if I'm able to generate all the three values, immediately I'll able to eliminate the x and y from equation number 4. And I'll be successfully eliminating x and y, I'll get this equation. That is our objective here. So I'm going to start with the calculation of cos of x plus y. How to generate cos of x plus y and cos of x minus y. So I'm going to take the first equation and square it, and plus second equation and square it. So the moment you take first equation, that is sine of x plus sine y whole square plus cos of x plus cos of y whole square. Now if you square this, I'm doing this operation here, you will get this as sine square x plus cos square x, that is 1, plus sine square y plus cos square y, that is 1, plus you will get 2 times. You will get this as cos of x multiplied by cos of y plus sine of x and sine y. And this will be equal to, on the other hand, it will be equal to a square plus b square, as you can see here. A square plus b square. Now this will be 2 plus 2 times. This is a perfect expansion of cos x cos y plus sin x sin y will be expansion of cos of x minus y. And that is equal to a square plus b square. So from here I can write the value of cos of x minus y. So cos of x minus y will be equal to a square plus b square minus 2 whole thing divided by 2. Now let's call this equation as fifth equation. So I got one of the part which was very important for the problem, that is I got the expansion of cos of x minus y in the terms of ABC. Now I'll do the same thing. I got the third part. Now I'm going to calculate the second part, and second part is easy. Instead of squaring, adding here, I'm going to subtract here. I'll do the same thing here. I'm going to square and subtract here. Now in the previous slide, we have calculated the value of cos of x minus y. Now here I'm going to calculate cos of x plus y, keeping the operation same. The only difference is I'm going to subtract here. I'm going to square and subtract here. The moment I take the square and subtract here, I'll get this as cos of x plus cos of y whole square minus sin of x plus sin of y whole square is equal to b square minus a square here. Now if I open this, I'll get cos square minus sin square, that is cos 2x plus cos square minus sin square, that is again cos 2y, and then remaining is plus 2 times. We'll get this as cos of x cos of y minus sin of x and sin of y, and this will be equal to b square minus a square here. Now again I'm going to apply here cos c plus cos d. Why? Because here if I see this expression cos of x cos of y minus sin x sin y, this is a perfect expansion of cos of x plus y is written. So the moment I apply here cos c plus cos d, here we'll get this as 2 cos c plus d by 2 cos c minus d by 2. So we'll get this plus 2 times of we'll get cos of here x plus y is equal to b square minus a square. And here our objective is to calculate cos of x plus y. So that's why I applied cos c plus cos d here so that I can take something common. So from these two terms I'm going to take common 2 cos of x plus y. And the remaining term is here is 1, cos of x minus y and 1 plus 1. That will be equal to b square minus a square. Now from the previous equation I can put the value of cos of x minus y. And that will be equal to 2 cos of x plus y. From the previous equation, if I put the value is a square b square minus 2 upon 2. So this will be a square plus b square minus 2 upon 2. So I'm going to take the LCM and whole thing divided by 2 is equal to b square minus a square. So from here we'll get the value of cos of x plus y. So this 2 and this 2 will cancel out. From here we'll get the value of cos of x plus y, that is b square minus a square upon b square plus a square I can write. So let's call this relation as 7th one, because I think till 6th we have taken, so this is the 7th one. Now our next target is to calculate the value of sine of x plus y. Now we are only one step away from eliminating x and y. Coming on to the last part, we have to calculate only sine of x plus y. Now in order to calculate sine of x plus y, I'm going to multiply first equation with second. So first equation is sine of x plus sine of y multiplied by cos of x plus cos of y is equal to, I can write this as AB. So let's multiply inside. So if I multiply, I'll get this as sine of x multiplied by cos of x plus sine of y multiplied by cos of y. Now we'll get two more terms, that is, we'll get sine of x cos of y plus cos of x and sine of y, and is equal to AB we'll get here. Now I'm going to do one thing here, that is I'm going to multiply the whole equation by 2. So if I multiply the whole equation by 2, 2 sin x cos x will be sine 2x here, plus 2 sin y cos y will be sine 2y, plus if you notice one thing, this is a perfect expansion of sin a cos b plus cos a sin b. It's a perfect expansion of sine of a plus b. Now this will be equal to 2ab, and this will be multiplied by 2 as well, as because we have multiplied the whole equation by 2. Now we can do one thing here, we can apply sin c plus sin d. The reason why I'm applying sin c plus sin d is because immediately I'll get sin x plus y and that I can take common, and that's what we want to calculate here. So we want to calculate sine of x plus y. So if we apply, we'll get this as 2 sine x plus y, that is sine a plus b by 2 multiplied by cos of a minus b by 2. So we'll get this is plus 2 sine x plus y is equal to 2ab we'll get here. Now from this equation I'm going to take 2 sine x plus y common multiplied by, inside we'll get cos of x minus y and then plus 1 is equal to 2ab. So from here the value of sine of x plus y will be equal to 2ab divided by, here I can write this as or I can write 2 and 2 will cancel out here, so there's no need to write 2, so this will cancel out, ab divided by cos of x minus y and then plus 1. Now previously we have calculated the value of cos of x minus y. I'm going to substitute this value in order to calculate sine of x plus y. From here sine of x plus y will be equal to ab divided by, the value of cos of x minus y is, I think, a square plus b square minus 2 upon 2. So I'm going to take immediately LCM. So we'll get a square plus b square minus 2 whole divided by minus 2 plus 2 whole divided by 2. Here I've taken LCM, that's why plus 2 here. The final value of sine of x plus y is equal to, this 2 will come in numerator, that is 2ab whole divided by a square plus b square. This is our value of sine of x plus y. Now I'm going to substitute all the values which we have calculated, all the three values which we have calculated. That is sine of x plus y, cos of x plus y, cos of x minus y. And then I'll successfully eliminate x and y. Now we have all the three values which are required to eliminate x and y. So I'm going to substitute one by one. So in place of sine of x plus y, I'm going to substitute 2ab divided by a square plus b square here. And whole thing is divided by cos of x plus y is b square minus a square upon a square plus b square. And minus, plus here you'll get this as a square plus b square minus 2 upon 2 here. Now after taking LCM, I think this a square plus b square and this a square plus b square will cancel out. This 2 will go in numerator, I think. So we'll get this as 2 into 2 into 2, that is 8ab. Whole thing is divided by, let's take the LCM here. So we'll get this as 2b square minus 2a square plus a square plus b square will be multiplied with this term. So let's multiply with this term. So we'll get this as a square plus b square whole square and then minus 2a square minus 2b square. So if I calculate this, this is 8ab. Whole thing is divided by, I think, plus 2b square and minus 2b square will cancel out. Here we'll get this as a square plus b square whole square minus 2a square minus 2a square, that is minus 4a square. So I think we have proved after successfully eliminating this will be equal to C. We have successfully eliminated x and y and this will be our final answer, hence proved. And that'll be all.